Hello students, let's see another question which came in GATE 2020 Civil Engineering. This was question number 43 in the afternoon session. So the question states that the cross section of a reinforced concrete beam having an effective depth of 500 mm is shown in the figure. This was the figure. The grades of concrete and steel used are M35 and Fe550 respectively. The area of the tension reinforcement is 400 mm square, and it is given that the corresponding to 0.2% proof stress, the material safety factor is 1.15. This is corresponding to steel, and the yield strain of Fe550 steel is 0.0044. This is the figure and the relevant dimension is given. So it is asked, as per IS 456-2000, the limiting depth, that is the limiting depth in mm, round off to nearest integer, point to be noted, round off to nearest integer of the neutral axis measured from the extreme compression fiber is. So the reference to solve this question could be found out in the limit state of collapse flexure lecture in the course of design of reinforced concrete structure by Professor Nirjal Dhang, Department of Civil Engineering, IIT Kharagpur. So first let us see what all data is given to us. Effective depth is given as 500 mm. Material used is M35, that is FCK comes out to be 35, and the material used Fe550 as a steel, so Fi comes out to be 550, and the area of steel in tension is given as 400 mm square, and XU limiting is asked. So first let us draw the strain diagram. So this is how the strain diagram will look like. This depth will be axial limiting, and the strain in the compression will be maximum 0.0035, and the yield strain in steel is already given as 0.0044. So by using the concept of similar triangle, axial limiting divided by D would be equal to 0.0035 whole divided by 0.0035 plus 0.0044. After putting it in calculator, you would get at axial limiting equals to 0.44 D. Put the value of D, which is 500 mm, and after putting this in calculator you would get as 221.518, and in question it is asked round off to the nearest integer, so which would be equal to 221. So 221 would be the correct answer for this question. Thank you.